Okay, this is your geometry semester exam, page 6 of the review. Number 28, now we're going to start focusing on triangles, if you haven't noticed. Number 28, find the value of A, B, and C when triangles KLM and XYZ are congruent. All right, so for this guy, we look at the names of the triangles. That tells us which angles are corresponding. So K and X are corresponding. So if K is A, angle X is going to be the same size. Well, that doesn't really help us, right now. Angles L and Y are the same size. This guy is the same size as Y. So this is 108. And then M and Z are the same size. So Z, oh, there's one that we're looking for, 32 degrees. So I got B. B equals 32 degrees, right? Now I can find A since I know 2 of the 3 angles in this triangle. So 108 plus 32 is 140, and all 3 angles have to add up to 180. So 140 plus what equals 180? 40 degrees, right? So A has to equal 40 degrees. And then the last thing we're looking for is C, which is the length of this bottom side here. And LM up here is the last 2 letters. It's congruent to the last 2 letters here, Y and Z, which is this line. So 32 is equal to 4C plus 7. 32 equals 4C plus 7. Subtract 7 on both sides. 4C equals 25. Divide by 4. Divide by... They always give us weird numbers. C equals, what is that? 12.5. 6.25 or 6 1/4. C equals 6 1/4 or 6.25. Anyways, we had to solve for A, B, and C. So there we go. And you'll know whether it's multiple choice or select all that apply or whatever, how to put your answer, if it's a 0.25 or if it's a 1/4. I'm a big fan of using fractions unless they use a decimal in the answer. So I would probably stick to 6 1/4. All right, number 29, find the value of A, B, and C when these 2 triangles are congruent. So L is going to be congruent to angle Y. They're equal to each other. So I'm going to say 3A plus 50 equals 4A plus 46. Get rid of my smallest A, so this goes away, the 3A. 50 equals A plus 46. And then subtract 46 from both sides. 50 minus 46 is 4. So A equals 4. M and this angle Z, M is the last letter, Z is the last letter. They are congruent, they're corresponding. So angle M has to be 55 degrees, which is B. B equals 55. And we're also looking for C, which is this angle up here. So since we found A, we do have to find the measure of this angle, right? Or we can find this angle. A is 4, so 4 times 4 is 16. 16 plus 46 is 62. And 62 and 55 is 111 plus 117. So 117 plus what equals 180? Well, 180 minus 117. 80 minus 17 is 63. So this has to be a 63 degree angle. C equals 63. So we solved for A, B, and C for number 29. Okay, number 30. Another similar question. Find X and the perimeter of triangle DEF if DEF and MNP are congruent, right? So here we have DEF. We want to find X and the perimeter, okay? So what do I set this equal to? Well, this is side EF. How do I know which side is congruent to EF? Well, look at the letters. EF is the last 2 letters in the name. NP is the last 2 letters in the name. So this line up here is congruent to this guy. So 3x minus 47 equals 28. So I'm going to add 47 to both sides. 3x equals 40 is 68 plus 7, 75. So x equals 25. Once I know what x equals, I can plug it back in here. 3 times 25 is 75. Minus, oh, I already know what this is, 28, sorry. Duh, I don't have to solve for it. And then this side over here is congruent to this side, and this is 20. So I can just add the three sides together to get the perimeter. Perimeter equals 20 plus 28 plus 35, which is 48 and 35, 78, 79, 83. Mental math, if I messed up, let me know. 83, 20 plus 28, 48, which is almost 50, plus 35 is 85, minus 2 is 83. Yeah, that's correct. And the number 31, last one of page 6. What other information is needed to prove the two triangles are congruent? By angle, side, angle, by side, angle, side. So for these two triangles, it shows this is congruent and this is congruent. And that's all we know. So for ASA, angle, side, angle, that's two angles in a row plus the side between them. So we could either say angle L is congruent to angle T, or we can, is that a T or an R? OST, I can't see what the letters are. Whatever, this angle up here. I can say angle L is congruent to this angle, or I can say angle K is congruent to this angle. It looks like a D, doesn't it? I'm going to say it's an O. I'm going to say this is an O, and I'm going to say this is a T. So it doesn't really matter which one. So I can say angle L is congruent to angle T. And then I have to say that, if I said that, that the two, that the side in between the two angles has to be congruent as well. So ML would have to be congruent to ST. ML would have to be congruent to ST. So then we'd have angles, right? And the side connecting them. That would be angle, side, angle. For side, angle, side, we already know this first angle is congruent, right? So we need the two sides on either side of that angle. So we would have to say ML is congruent to ST. And we'd have to say MK is congruent to TO. No, sorry. SO. Right? It gave us this angle. It gave us this angle. So we have to say this side's congruent and this side's congruent. This side's congruent and this side's congruent. That would be, the two triangles would be equal by side, angle, side. Okay, kind of the same thing here. We have to tell what's needed. So it shows us that this is 90 and it shows us that this is 90, and that's all we know. So to prove this is congruent by angle, side, angle, you can just pick another angle and then pick the side between them. Doesn't really matter which one. So I could say angle W is congruent to angle K. And if I said W and K are congruent, I got to say the side between them is congruent. It already shows me that this angle is congruent to this angle. So WV would have to be congruent to KX. And that would be angle, side, angle, and angle, side, angle. If I wanted to use side, angle, side, I could say, we already have this angle, so I need to name the side on either side of that angle. So I could say WV is congruent to XK. Oops, XK, they're like similar. And I could say that XV is congruent to itself, because both triangles share that, right? So that's how I would name the triangles congruent by either angle, side, angle, or side, angle, side. Remember, when we use angle, side, angle, we're comparing two triangles, but it's saying an angle and another angle and the side joining them. That's angle, side, angle. It's literally three things in a row. If we said side, angle, side, it would be like side here, angle here, side here. It would be two sides and the angle that joins them. Those would be congruent. So don't forget what those shortcut rules are.